uh, it, you basically have two different variables in the equation.
Okay, two variables.
Yeah.
Okay, fine. Just a moment. So what are variables?
They can have any value. Yeah.
Hmm.
They do not have any definite value. They change depending on the equation.
Yes. Okay, more or less that's the definition. So linear, what is linear then? Linear equation. So can you tell word by word what is linear, what is equation?
Okay. So a linear highest degree is one,
Okay.
and uh, the equation comprises of variables, constants, and uh, arithmetic symbols. And yeah,
Okay. Can you repeat?
yeah. So linear means the equation, the degree is one,
Hmm.
and uh, equation is comprises of variables, constants, and arithmetic symbols,
Hmm.
and two variables are so the equation comprises of two variables.
Hmm.
Yeah.
Good. Yes. So, nice try. So what is the difference between polynomial and equation?
Polynomial is just a singular term, while an equation has is many terms joined by signs.
Okay. So let me give an example. So 2x square plus 3x plus 2. So what is this? This equation where or polynomial or expression? What it is?
Equation.
It is equation. So equation basically, if you see, we equate something. So we have not equated anything here. So
Mm.
is this equation in any way? Just going by
Yeah.
the simple
Uh,
English meaning. So can we call it as equation? We need to have something,
equation.
yeah, something equal. Or
Yeah.
let's
So
put
this
it
we
in
can't.
another way. There should be
Yeah. This
right
is
and
equation.
like both
Yeah.
some equating sign should be there. Then
This is
only it will,
equation.
yes. Then only it would be,
Okay.
yeah. How linear you have understood, it should be the highest power should be the highest power should be 1.
One.
So suppose 2x 2, and we have on the right side we have something, say suppose 0. Okay, so we now got linear, we got linear, we got equation.
Yeah.
Okay, two variables. What is two variables?
So it will be 2x plus y is equal to 0.
2x plus y is equal to
Y.
0.
Yeah.
Is it what you wanted to say?
Yeah.
So why this is two variables?
That has two variables.
Okay, this has two variables. So is it linear?
Yeah.
Is it equation?
Yeah.
Okay. So now you got 75% of this.
Yeah. This pair of
Yeah. So what is left is pair. So what is this pair now? Pair means,
which means another one,
yes.
another
So can you give
similar
me
one.
another example?
Okay, x minus y is equal to 3.
X minus y is equal to 3. Great. So yes, this is what exactly it means. So whenever we have two equations and that comprises of two linear equations and which has two variables included in it.
Okay.
Okay, so that is pair of linear equations in two variables. So hope you got the word by word meaning
Yeah,
and
it
the
was.
gist of that?
Mm.
Okay. Now we'll be what we'll be studying in this is we'll be these are the topics. We'll be studying the representation. How do we represent this? So suppose twice number of chocolates and thrice number of toffees costs us 10 rupees.
Mm.
So how do we represent? So this is included in the representation, and
Okay.
primarily it is what we call as word problems. So this is what it is.
Mm.
Next is
Okay.
we'll be solving them. We'll be solving them.
Yeah.
So now this has two parts. One is graphical.
Oh,
Second is algebraic. So these are the two methods that we'll be using. We'll be studying both of them.
okay.
So you can note down these topics.
Mm.
In this further we'll
Yeah.
be having three: substitution, elimination, and cross multiplication.
Okay.
So what are the three methods?
Substitution, elimination, cross multiplication.
Yes. And there be three cases, three different cases of the solutions. Three cases of solutions. So I will not give the details right now, but like what kind of solutions can we have? It will be will it be one solution? Will it have two solutions? In many solutions, infinitely many solutions, parallel, or what kind of? So that
Okay.
is what we'll be studying in this chapter. So
Okay.
okay with this. So now
Yeah.
first we'll be studying is how do we represent this. So for representation, I will take simple example. So suppose the number of the question is that the sum of the number of boys and number of girls in the class is 10, and the difference between the number of boys and the number of girls is 2. So how do we represent? So we take this as sum is 10 and difference
Yeah.
is 2. So how do we
True.
represent this? So number of boys is x.
And
Okay.
yeah.
Number of girls is
10 minus
y. Number of girls is y.
1.
So
Okay.
no, it's not that. Now you can tell me what is the
Yeah.
sum?
X plus Y is 10.
Yes, x plus y is equal to 10. Next, this is the first equation.
Then X minus Y is 2.
X minus y is 2. This is the second equation. So this is our pair of linear equations in two variable,
Yeah.
isn't it?
Yeah.
Okay. Now we'll do few examples. So can you just let me? So we'll go with the first example in your textbook.
Okay. Let us
It's
take
not
the
clear
example.
actually. It is not clear actually. It
Okay.
is being continued from
Okay.
explanation above, so we'll not take this example. We'll take example 2.
Yeah.
Yes.
Romila went to a stationery shop and purchased two pencils and three erasers for rupees 9. Her friend Somnali saw the new variety of pencils and erasers with Romila, and she also bought four pencils and six erasers of the same kind for 18 rupees. Represent the situation algebraically and graphically.
Yes. So first we'll
Mm.
take this. We are studying, as of now, we are studying algebraic representation. We are just understanding representation right now. We are not understanding the solution part. How
Yeah.
do we solve?
Okay.
We are just starting with the representation. This,
Algebra.
okay? We're just studying this. Solution, it will come next.
Okay.
Yes. So how do we represent? So we take one of this as each, like name each of variables. So pencils, let the number of pencils be
Right.
x, the number of erasers be
Why?
y. So
Yeah.
now what equations would we be having?
So 2x plus 3y is equal to 9.
Great.
And 4x plus 6y is equal to 18.
Okay. So this is the second equation. Okay. Now we'll represent it graphically. So we'll continue with the first example. Now I thought we would be having more examples, but you have a good enough idea. So we'll not continue with other examples. We directly go to the graphical representation. So before that,
Okay.
we'll just shortly discuss what case we have now, because this is a linear equation. This is the linear
Mm.
equation. So if we draw each of the graphs, if we plot the graphs, plot the curves,
Yeah.
what kind of shape could we expect?
A line.
Of course, a line. So now we have two,
Mm.
like we have two equations. So how many lines would be there?
2.
Obviously two.
Yeah.
So if you have two lines,
Yeah.
if you have two lines, so what different combinations can you expect from these two lines?
Oh,
What, like they will cut, they will be parallel, they will intersect,
okay.
whatever. So I'm we have been given
Parallel.
this. Yes, but
Then one case it can intersect,
okay,
and one can be directly on the other.
overlapping, right?
Overlap.
That is basically coincident.
Mm.
Okay. So can you you have studied drawing the graphs. So can you draw the graph for our
Yeah.
first example, this one?
Yeah. Okay.
You can
So
sketch it roughly on your.
yeah, x is 5. Yeah, x is 5, y is 5, x is 8, y is 2, uh, x is 2, y is 8,
X is 5, y is 5, x is 2. This is what you
y
said.
is 8. Yeah,
Y is 8. Okay.
and x is 8, y is 2.
Okay.
And the other one, x is 4, y is 2, x is 3, y is 1, x is 5, y is
This is
3.
0. You said this 0 or 4? 4.
4, 4.
This is 2.
4, y is 2, x is 5, y is 3, and x is 3, y is 1.
Okay.
Yeah.
So let's plot this. So we plot this. 1, 6, 7. you know how to plot na?
Yeah.
Okay. So where would be these points? 5, 5. So 5 here
Yeah.
and 5 here. We're going with the first.
Yeah.
What? What's next?
Two,
2, 8.
two.
2, 8. So better draw this one 8, 2.
Yeah.
So
And you can join.
this obviously would hit at 10. Whenever
Yeah.
y would be 0, it would be
Yeah.
10.
And next. Yeah.
So now this is our first graph.
Yeah.
Second graph 4, 2,
Four and two. Five and three.
5 and 3.
Yeah.
Okay, 3
Intersecting.
and so something like that.
Intersect. Yeah.
Yeah. So this is our x minus y is equal to 2. Okay.
Mm. Yeah.
Now we can find the intersecting point. That's next step. But this is the graphical representation.
Okay.
And this is the algebraic representation.
Yeah.
Okay.
Mm.
So you can just quickly note this as you want to. In the representation, we have to algebraic and graphical representation, and quickly just write the equation and a simple graph.
Yeah. Yeah. No.
Done.
Yeah.
So what did we study till now? Just quickly.
The graphical
From
representation and
starting. From
algebraic.
starting.
Okay. So there are two types of okay. So linear equations. An equation is something which equates to something else.
Okay.
It consists of variables and constants.
Hmm.
Um, then an equation containing two variables is linear equation in two variables.
Hmm.
And an equation with the highest degree as one is a linear equation.
Great.
And a pair of linear equations is two linear equations.
Okay.
Having the yeah, and in two variables, that means the linear equations have the same variable.
Hmm. Hmm.
Mm.
Okay.
And yeah, and we did the different types of representation of these equations, algebraic and graphical.
Hmm.
So yeah, algebraic is written in yeah, x plus y is equal to 10, written like that, and graphical is plotted on a graph. So,
So the general
and the
equation of
three types of
yeah the
possibilities that
general
we have.
equation
Yeah,
of this graphical representation is this. So
yeah,
if we have two equations, then we can write this as
yeah,
this. Okay,
yeah,
you can put this down. This is the general equation.
yeah.
Now, if graphical, okay, so graphical is done. So what about graphical?
Graphical, it's represented on a graph. So
Hmm.
in a linear equation, you'll get two lines which may be parallel, intersecting, or coincident.
Yes.
And
So
yeah,
these are the three cases. You can note this also. It's very simple chapter, very simple definition, simple chapter,
okay.
and very useful in solving. It is like used in further topics.
Yeah.
So one of the important parts of algebra. Okay, so you noted.
No one.
Okay, you can note this down.
Yeah. Yeah.
Okay, so these are the three cases.
Yeah.
Now will not we will, but you will. You need to
Okay.
draw plot the few of the graphs. Okay, so you have a graph
Okay.
paper at your home.
Uh, yeah, I'll just give it.
Yes, sure.
Yeah.
Okay, so pencil, scale, eraser, everything's
Yeah.
ready.
Yeah.
Okay,
Yeah.
so we'll be we are ready for the mission graphing.
Okay.
So we'll do from the exercise the solved example you can try on your own. We'll start with the exercise.
Okay.
So in both the cases what we need to do, in the question we have to do both the cases, drawing, representing it algebraically and then graphically. So let's start with the first question.
The first one you did in school today, actually, early in the
Okay,
morning.
so you don't want to
I
do.
remember. I mean, I remember the answer. It was just,
Okay, you remember the answer.
we haven't done the. We only did the first question in the morning.
First section means
First question. First question.
first question. Okay,
Yeah.
so
Yeah.
in that case, in that case, we can Okay, so we'll do the second question, no problem.
The coach of a cricket team buys three batsmen to score
You can
for
tell me the
3,000.
algebraic representation at least.
Okay, yeah. So let Aftab's age be X and his daughter's age be Y. Right. Yeah. So 7 years ago,
Hmm.
Aftab's age would be X minus 7 and his daughter's age would be Y minus 7.
X minus 7 and y
Y
minus
minus
7.
7.
Okay.
But it also says so 7 years ago he was sent 7 times as old as
Hmm.
his daughter. So X minus 7 is equal to 7 times Y minus 7.
Okay.
Yeah, so X minus 7 is equal to 7Y minus 49. So X minus 7Y is equal to minus 42.
Minus 40.
Two.
Okay.
And then 3 years uh, later, uh, Aftab's age will be X plus 3. My daughter's age will be Y plus 3.
Hmm.
So it also says X plus 3 is equal to 3 times Y plus 3. So it's 3 times as old. So X plus 3 is equal to 3Y plus 9.
This is interesting age combination, by the way.
And plus 9. So X minus 3Y is equal to 6. Yeah, and now we have to plot the graph. Yeah.
Okay.
Mm.
So, a quick tip and guideline for plotting the graphs. If we have bigger numbers, suppose in the next question that would be multiples of 100, so you need to take it
Mm.
accordingly. Okay.
Yeah.
And in this also, if you carefully see, if we see the graph, that is not touching actually. It seems to be touching somewhere. It appears that it will touch somewhere, but it is not
Mm.
clearly touching. Do you remember that?
Yeah.
I'll share the.
In the graph.
Yes, the graph is not exactly, it's not clear that it will touch.
Yeah.
It just appears. So just let me share the graph. So got the graph.
Yeah.
So this is the first one. This is the first.
Mm.
This is the second equation. Now it doesn't appear like it seems, but it's not clearly quite that we can understand that it's
When
intercepting.
we read in the notebook,
Hmm.
actually, ma'am made us make divisions of 10. So 10,
Yes,
20, 30.
yes,
Yeah.
exactly,
Yeah.
exactly.
And
So
then,
that is what is needed. So in case of bigger numbers, we need to take the units and the partition, the gradations
mm.
accordingly.
Yeah.
And one more thing, just because we solved, yes. So here, if you see, I think I probably would have told you this earlier. You can take this one time zero, this another time y as zero. Okay, so this becomes 10, this becomes 10. So this one way of doing it, quick way of doing it.
Okay.
Now this is of course 10. If it was simple, then it would be a lot easier,
Yeah.
na? And
Yeah.
same in the case of this one also. You can have
Mm.
x y. So if we take x as zero, so y is minus 2. and if
Mm.
this is 0, then obviously
Mm.
becomes a lot easier, because see, if we
Yeah.
have the points, if we have this 10 0 na, so just
Mm.
plot one here, just plot one here, and then just simply plot at
One.
10, just plot at here, so just connect
Mm.
them, isn't it?
Yeah.
So that's far more
Mm.
easy. Okay,
Yeah. Okay.
you got the point.
Yeah.
Okay, so continue with the second question.
Okay. Fourth of a cricket team buys three bats and six balls. Leadership buys another bat and three more balls the same time. So, okay. So let the number of bats be X and the number of balls be
Your
Y.
voice is a bit low, in case you can.
Uh,
Yes.
yeah. Okay. Let the number of balls bats be X and the number of balls be Y.
Hmm.
So, so 3x plus 6y is 3,900. And x plus x plus 3y is 1,300.
Hmm.
Yeah. And so now we have to, so the values of x and y we have to find.
Okay.
Um, so, so x can
We need
be,
not find. Okay, for graph you're saying.
yeah,
Okay.
for the graph. So in the first case, we can have, uh, so in the first case, you can have x is equal to 100.
See, because here three seems something seems common here, na? Three seems
Yeah,
common.
yeah,
So
yeah.
you can just remove that.
Okay.
That is one possibility. So if we remove, we'll have 2y is equal to
Equal
1,300.
to 1,000. Yeah.
This remains same.
Hmm. Yeah. So yeah. Now we can take x as 300
Hmm.
for the first case. Yeah. X as 300
Hmm.
and y as 500.
Hmm.
Then we can take x as 1,100
Hmm. That's
and
interesting.
y as 100.
Okay.
100.
Okay.
Then
Strange
other
story.
one, yeah.
Anyway, go
Uh,
ahead. Go ahead.
then for the next one, it would be um yeah, x. Yeah. So x would be 1,000
Hmm.
and y would be 100.
Hmm.
Then x would be 100, y would be
Okay.
400.
Okay. So you got that.
Yeah.
So you can have the graph done.
Yeah.
Try.
Make it.
So what are the gradations you will take? Steps you will be taking?
Uh, so I'll take each as 100,
Yeah,
each division as
that
100.
would be good. Yes.
Yeah. So it intersects at 1300 comma 0.
Can you repeat?
The line intersects at 1300 comma 0.
Okay, so just one more time.
Yeah, 1300 comma 0.
So where, like, for both you're saying?
Yeah, it intersects. The line intersects at this point. Yeah.
Okay. Okay. That's why is it so? Can you tell me? Just seeing this, just by seeing this, looking at this.
Um.
A hint. What's the value of y here?
0. Yeah.
0.
Oh, right.
How?
Because 2 into 0 would be 0.
Hmm.
So if x is 1300, 1300 plus 0 is
Hmm.
1300.
Hmm.
And same with 3y, 3 into 0 is 0. So
Hmm.
1300 plus 0 is 1300.
Yes. So the fact that it is the solution of both the points. Solutions mean it's intersecting. It would lie on
Yeah.
both the graphs, both the curves, both the
Yeah.
lines. So it is lying on both the lines, and it must satisfy both the lines. Then the point
Yeah.
x
Yeah.
y value is there. Now, if we have, just we can look, y is 0, so obviously x is 1300. So, and both is satisfying this. So
Yeah.
this is the probably the right solution. Okay, so have you done the graph?
Yeah, I have. I can maybe show it on the screen.
Okay, okay, great.
Yeah. Yeah.
So let's quickly go to the next question. So you got the, like, how we deal with these questions. We have we have linear equations, and we have two linear equations in two variables. Okay, so the first would be obviously of this form, and second would be of this form. Now we can represent any word problem, any real life situation in the form of a linear equation, if it's possible. Not like, not everything can be done. Suppose the number of say number of toffees is x, and number of chocolate is square of the number of toffees, x square. So that is not obviously possible as linear equation, isn't it?
Yeah. Yeah.
But if it is possible, then we can represent it in a algebraic form and graphical form. And algebraic form, we have constants and variables, mathematical operators, plus minus, multiplication, division. And because it is
Yeah.
an equation, we would have something on the right side of the equal sign.
Yeah.
Yes. And we have two equations. And then for a graph, how do we graph? We take the x and y values, to at least
Yeah.
two pairs for each of them, and then we plot on the graph. And if it is intersecting or not, as in the case in the next question that we'll be doing. So might,
Okay.
what are the three cases that are possible?
Intersects at one point, parallel, or coincident.
Great. So this is what we have studied in the this class. Okay, this
Yeah.
was the gist of this. So continue with the next class, and probably we'll stop then.
Okay.
You can continue the third question.
Yeah, I can't see
You can't see.
I can't see the beginning of the question.
Oh. Okay.
Yeah. The cost of 2
Just a moment.
kgs of apple. Okay.
Yeah.
The cost of 2 kg of apples and 1 kg of grapes on a day was found to be 160. After a month, the cost of 4 kgs of apples and 2 kgs of grapes is rupees 300. Represent the situation. Okay. So let 1 kg of apples be X. Okay.
Now we need to
Grape.
specify this whatever the unit is this. Like in this years is there. So that is very
Yeah.
important.
Okay.
You get confused.
Yeah.
Hmm.
Then grapes cost is equal to y per kg.
Hmm.
So 2x plus y is equal to 160. And then after a month, 4x plus 2y is equal to 300. So 4x plus 2y is equal to 300 can be written as 2x plus y is equal to 150.
Okay.
Yeah. And now, so find the values of x and y. So
Hmm.
x can be for the first case. mm, Yeah, for the first case, x can be 50 and y can be 60. And x can be 20 and y can be 120.
Okay.
Yeah. And then for the second case, x can be 50, y can be 50. And x can be 20 and y can be 110.
Sure.
Yeah.
Please recheck.
Uh,
X
yeah,
is
x can be 20 and y can be 110.
110. Okay.
Yeah.
Okay. I misheard it. I heard 100. Okay.
Okay.
Fine. So graph.
Yeah.
So what are the gradation steps that you'd be choosing?
Uh, I'm taking 10.
10. Okay.
Yeah. I can't see
Yes.
value,
Okay.
the values of. Yeah. Yeah. The line intersects at 70 comma 20, but it doesn't.
70 comma 20.
Yeah, it doesn't fit. Oh, yeah, wait. Maybe that's 110 comma 10, not 110 comma
No,
20.
does it intersect at all?
No, one second. I took the wrong point.
Okay,
I took one
okay.
of the points. Yeah, it's parallel.
It is parallel.
Parallel. Yeah.
Yes. Okay. So this is parallel. Okay. So two homeworks for you.
Okay.
These are from R.S. Agarwal.
Okay.
You noted. You noted it down.
Yeah. Yeah. Okay. No.
Okay, fine. So this you can try, and
Yeah.
the graphs that you have right now done, two graphs. So that also you can send with a snapshot along with these
Okay.
two homeworks.
Okay.
Okay.
Okay. Yeah.
And
Yeah.
in the next class we'll be continuing. So any doubts coming from this session?
No, it's quite easy.
No. So what did we study today? Just quickly.
Okay. So the meaning of a pair of linear equation,
Mm.
then the types of ways of solving the equation, the
Mm.
algebraic and or representing the
Mm.
algebraic and the graphical ways,
Mm.
and then the different possibilities of number of solutions for the linear equation in two variables. The lines can be parallel, they can intersect at one point, or they can be coincident.
Yeah.
Then, mm, yeah, then the formula A1x plus B1x plus C1 is equal to 0, and A2x plus B2x plus C2 is equal to 0.
Yeah, remember these two equations, the standard forms, because we'll be drawing a short table, so in which we'll be
Okay.
uh, algebraically just representing the three types of intersection, like whether it is intersecting at one point, uh, or it's not intersecting at all, that's parallel, or it is coincidence.
Yeah.
We'll be representing this using this a1b bx plus a1x bx b1x y plus c1 is equal to 0, a2x
Yeah.
plus b2y plus c2 is equal to 0. So just remember this. Okay, so we'll stop here.
Yeah.
Okay,
Yeah.
so end with the solutions, right?
Mm.
Okay, good night.
Okay. Good night. Yeah.